All right. Okay, let's get started. So before I start, I wanted to um, kind of get some sort of idea. If you could write on the chat if you have used GitHub before or any sort of version control. If there's other sort of version control. So could you please type on the chat if you have used either Git or SVN or whatever else. Okay. See, one person has. Okay, we have a handful of people who have used this. Um, just a heads up, this is going to be a skill session where we are covering the basics. So there's sort of like the fancier stuff that I will try to avoid. We will just be covering the fundamentals. However, I think this would be of good value for you because I'm not only just going to talk about Git, but also kind of point you towards the resources that we have available for your projects. Quite a few teams do software projects, but then they don't necessarily use the EPICS GitHub resources. So I'll kind of touch on that as well. Okay, so to start again, why do we need version control at all? On a high level, there are three reasons why we would ever use version control. Um, it originally started out as a form of remote backup. Whenever you've written code and you have software that you're working on, in order not to lose your work at different intervals, um, version control such as GitHub may be used as a remote backup. So your code is stored not only on your computer but in some remote location. And then it kind of evolved into the having revision history as well, which is very valuable. Um, so having a revision history, it allows you to track all the changes that you've made on your code over time. And the benefit that you have in doing this is that if something messes up or you've created a bug throughout your process, you can backtrack and resume exactly at the point where it was working out fine. Ideally, you can avoid a lot of these bugs by following best testing practices, but these things happen. And it is very essential to have the revision history such that you're able to track back at various different points of your development process and kind of resume where things worked. And then finally, we have branching. So if you're not familiar with GitHub, you may have heard this word thrown around. You may never have even heard this word. That's fine. Branching is simply you, as a developer, when you take a copy of the main code that is running and working, and you work on that copy to add your changes and your new code to whether you're upgrading it, fixing a bug, whatever. You're making changes in this copy of the code. And then once you've validated that changes you've made are working on this branch, then you put it back in the main repository, the main working copy. So on a high level, these are the three reasons why we would need version control. To allow version control, we have a wide variety of platforms. We have GitHub. I know Imagination Station in the past has used Bitbucket. There's also GitLab, SourceForge, Beanstalk. We have all of these. But I will be, I'm gonna go through just uh, the Git process, and you may apply it to any of these. EPICS provides you with enterprise level GitHub. So enterprise meaning you have a lot more storage capability on your repository, as in you can keep a lot more files. And you have more advanced options to kind of like pull requests and stuff like that, which I may touch on. So if you're a CS compy or anyone involved in software development, if you have you may have heard these words. Sound like jargon, but clone, commit, push, pull, merge, branch. These are all generally associated with Git version control. So if it sounds like it means nothing, that's fine. We're going to go through it over the course of this skill session. So I'm going to actually use this as an opportunity to go to the GitHub website, which does a very good job of explaining the flow of everything. So in our development process, we have at the top here where you see in purple, or the top line is your main working copy of the code, right? And so anytime this is what happens in any software engineering team where we do version control, is the top line, the thick blue line is the main copy of your code. That's what they refer to as the master branch. Master branch is the main working copy that you've tested, you've validated, you know it's working. And anytime you have to make a change, you need to add a new feature. For example, we create a branch. Let's say I work at Google and I'm adding a new feature to the Google Drive. And so we have the working part of Google Drive, which is the top branch, the main master branch, which is the red line, or the blue line, the thick blue line. And then I pull a branch out of it. I create a branch, and then I work on that branch, which is a copy of the master branch, and I add my code. And over time, once I have added my code, then as I'm adding my code, I add commits, which means that each time I commit a change in my code, then I'm telling the system to track this change. And then finally, once I am ready to kind of submit the code, then I open a pull request. The pull request is more specific to GitHub, but a pull request is basically saying this person on the team has finished writing their code and now they think it's ready to be put back into the main working copy of the code. This generally prompts some sort of code review. In your teams, I would recommend doing code reviews if you are not doing that already. So if someone has written code, then they would do it in their own branch, and then they would open a pull request, and everyone in the team would get together, review the what has been put in the pull request, and validate like, okay, this is not going to break the code, the main code, so we can merge that into the master branch, which is the working copy, like I said. Yep, it says here, discuss and review your code, and then you deploy, which is you merge into the master branch. So on a high level, that's the flow, but this is how it's kind of laid out. Your version control system consists of the server, which here is GitHub. That's a remote repository that generally has the working copy of your code. And then you have your local environment. It may not necessarily be local. You could be working remotely, which a lot of people do nowadays. You SSH into some sort of remote server where you're working on the code. But anyways, wherever you're working on the code, you have what you call, you have the dev environment, So in there you have a working directory, a staging area, as well as the local repository. The working directory is just the folder structure that you have, like your folders and files that are in a given location that are being tracked for version control. The staging area is specifically which one of those files are you having Git keep track of, and the local repository keeps track of um, specific changes that you've made over time to these files that are being kept track of. This, I hope, clarifies a little bit. I know it wouldn't fully unless I go through some sort of example, so be patient if you still don't get it. And so the first thing I would like to talk about is what cloning means. So you will see this term, and this is probably one of the first things that you would do if you are using a Git repository. Cloning essentially means you're taking a copy of whatever piece of code that is sitting on the repository, and then you're copying it into your local directory. Quick example. I was gonna do the demo at the end, but then I feel like it would make more sense if I just showed you here. So I am in the EPICS group over here. And then I'm going to clone one of the repositories. Let's see. Let's pick a random repository here. Hope. Sure, looks like someone built a web scraper, and I'm going to clone it. Cloning generally, what happens when you clone is you have a link over here, and this is a repository link. You take a copy of it, and I'm going to use my terminal. Is anyone unfamiliar with using shell scripts or Linux commands? I'm going to be using a combination of shell and then specific git commands. So bear in mind, so what I have in my local directory, let me show you how it actually looks like the folder structure. So personally, this is how I keep it. I have in my documents, I have a specific GitHub folder, like you see here, and these are all the repositories that I have track of, right? And for each one of them, we have like a version control system. I will show you like one of my personal projects is I have a software that detects political bias. So I have this here. You see all these folders here. The same folder structure, if you go on my GitHub profile, you'll see something similar. I'll go into my own GitHub profile. So the same folder that you see, like I named it BiasNet. So you can see the exact same folders here are replicated in my local directory. So archive or bin, data, doc, docker, docs. So you will see all of them here. The source code is here. My deployment code. So all of this that you see over here on this GitHub platform, I have developed on my local right here. And then I kind of pushed it to the remote repository. Anyway, so I'm like kind of diverging away from the presentation. So this is what I deployed. I'm gonna get back to this real quick. Yeah, so cloning or repository. Let's take a quick look at how you clone. It's pretty simple. I'm gonna clone This one over here, Hope. I don't know which team this is, but okay. Generally, what I do is I make a folder. Here I'm doing mkdir. Um, let's call it Hope because that's what the repository is. And over here, I just, in order to clone, I initiate GitHub, which is git init, and then I clone exactly this repository. Okay, so I cloned that, and then I go back to my folders, and let's see. Oh, I accidentally put it outside my GitHub folder, but then when I go into Hope, you see exactly the same files that you see here on the website. And that's essentially what cloning is. I took what is in the repository and I pulled it down into my local. And on that note, I will get back to the presentation. So that's what cloning is. So there's a difference between cloning. You also hear the word pooling. So cloning is you're just taking a copy into your repository, and it's not doing any comparisons to the directory in which you're putting it. So pooling generally happens when you already have some code that may be different from what's in the repository. And so when you pull, you're kind of updating your local repository and having Git keep track of all the exactly what changes have happened in that repository. So that's about it. And yeah, when you do make a change in the code, what you do is you add your the piece of code that you made the change into onto the repository, and then from there you make a commit. So commit means you're telling Git to keep track of any further changes that happen to this file. And then finally you push, meaning you are sending it into the remote repository such that everyone else can see it. Okay, I know I really prefer to do this in person. Um, so if you do have questions, please ask me. I want to start. Um, for those of you that have not installed Git yet, there's different ways you can do that. If you're using a Linux device, I have put the command over here. If you're using a Mac, you can go directly over here. And then you go into your terminal and then you just do that. And Windows as well, you have the download files. So that's how you can get set up with Git if you don't have it installed already. And I kind of jumped the gun and went through the basic commands already, but I will go through the basic commands. So the first thing you should know is when you are, like I did earlier, when you are looking to start a repository, you would want to do git init, which means you're telling the Git to start kind of open, basically. And then the next is add. So for git add, that's when you're telling you're telling Git to keep track of a given file. And then git status generally tells you what files are there and what are being tracked. So I'm gonna quickly go through an example to run through these. So they may sound like gibberish right now if you've never used Git before, and I'm sorry about that. And we have commit, which means I've made some changes in the file and I would like Git to keep track of the changes. Um, So each time you make a change, basically when you're saving a file, ideally you would like to commit it. That way, Git keeps track of all the different commits. And so whenever you mess up or something happens, then you can roll back to the exact commit that worked. And then push basically means that you are sending your code from your local into the repository. Pull is the other way around. And then I just talk about clone. Um, yeah. And just an FYI, you can also download a UI version. So what I am doing here is command line, which is not always, it's not the most user-friendly, but I think it is for me, the safer and more comfortable option. But I also have a Git UI. So I'm gonna pull that up and show you guys how that looks like. So Git UI, you have kind of looks like that. So if I go to the project, my own personal project, it has a list of all the commits that I've done. And over here, it shows the diff meaning the difference between the old file, the new file. The additions are shown in green, the removals are shown in red. So it does this for every single file that you write. And the main benefit that I see with using a user interface is this visual diff. Um, that way I can clearly know, okay, these are the lines of code that I've changed. These are the lines of code that I've added, right? So that's the UI. You can also do all of these commands. You can commit over here in the bottom left-hand corner. You can pull, you can push. Yeah, everything you can do, except I personally prefer the command line. And I think when if any of you are trying to like go for software internships and things like that, some companies ask interview questions on Git, and they'll ask you what you would do in various scenarios if you're using command line. So as people generally respect you more, I guess, if you use command line, especially in industry. So that's the UI. And so now I would like to introduce you to the Purdue GitHub. So Purdue offers an enterprise level GitHub, which you guys have access to. So if your team currently is using a form of Git version control, but is not yet on the ITAB GitHub, I know Imagination Station uses Bitbucket, which is a free version, but you guys can move over to the enterprise level GitHub. You can basically copy over everything, and it keeps track of all the version history on the Purdue GitHub, the EPICS, specifically EPICS GitHub. So there's this EPICS group here. I'm gonna click so you can see what it looks like. Yeah, so we have all the different repositories of the different teams. Um, you can see here all the commits are kept, and you can kind of step in at different points of the history of the code and see what it looks like. So here it shows you the stuff that has been added, for example. So yeah, this is really cool stuff. And if you're working on a group project and you don't have Git set up, it's like a big red flag. So there's supposed to be way more teams than this here. So if you know that you haven't set up your GitHub on the EPICS repository, um, please go ahead and do that for your team as soon as possible. And if you have like specific questions on how to set it up, then myself, or Jorge would be a good resource. And yeah, I'm just gonna quickly demonstrate, specifically using the Purdue GitHub, how I can pull the code, how I can make changes, commit, track the changes, and then finally push the code onto GitHub. So at least I think this may give some idea of what this whole deal is about and clarifies some of the jargon that is used. At this point, before I go into demo, are there any questions? Okay. So I will go to the skill session repository. So in the EPICS group, there's a skill session repository. So I used this last year where we did it in person in lab, where I had everyone kind of make a branch for themselves, make the change, and then submit a pull request. So I'm just gonna click on this person here and or see the pull request they've submitted. So I had over here just a file, just a random file where I printed out random things. And so I asked students to go in there and make modifications to the code. So print out their name. And this person here printed out and submitted a pull request. They said, hello, my name is Lydia. And then they removed the line that I had, which I said, hello, I'm your TA. My name is Kaushik. What's your name? And so they removed it. They put a plus, or they added their line, and they submitted a pull request. So when this happens, you guys can, as a team, review all the changes that are being made, and then finally you can merge it to your main code. I am not going to merge this, but I will kind of do a quick demonstration. So I am using the terminal on the side here as my directory, my local directory, and then I will be kind of playing around with this. I'm going into my GitHub folder where I have an EPICS specific directory. And then within that, I already pulled the skill session, but then I'm going to do it again just to demonstrate. So I have some of the basic commands here. I have already, I believe I should have initialized Git. So Git init, and then Git status generally shows you which files are tracked, which files are not tracked. Give me one sec. So this is what it would look like in your local. EPICS. Actually, this is not it. I'm going to redo this. Okay, from the start. All right, so I am going to initialize Git by saying Git init, and then I pull the code. I take a copy of the code by saying, or basically copying this line. So git remote add origin you're basically telling Git that take this URL link and then move it into my local. And so that's what I'm going to do. And then git pull origin master, meaning pull the master onto my local directory. And so when I've listed out the files here, they are exactly the same as what we have on this repository. So images, readme, requirements, hello.py. When you go here in my folder that I just made, it's you see the same stuff here. And let's say I make a change in this, right? I can create a branch of my own here. So I've put out instructions on how you can create a branch. So git branch. I'll make my branch with my name, git branch Kaushik. And then git checkout basically means copy out what's in the master branch into this. And then I will make a change to this file. I am going to say okay. So I did git status and it's saying this file has been modified, hello.py. So I can add that. And then I can make a commit saying I made a change, keep track of this thing. And then I can push it back to my branch over here. Oh, it looks like I'm still on the master branch, meaning I'm working off of the main copy of the code, which I should not do. But just to show you how to push this back onto the master branch, I'm going to do this and show you guys how it's going to reflect on the repository. So git push origin master, meaning basically take whatever changes that I've made in my local and put it now on the repository. So if I refresh this, you will see here, the change that I made here is shown here. I printed the line, this is a demonstration, and so you'll see that here. And also, let me close this for now. And also you can see the diff over here. When you click on the file, you click there, and you'll see the diff over here. So that is a, I guess, basic demonstration of how you can use Git. Again, the purpose of this skill session is to kind of get your feet wet and not necessarily make you an expert in any way. If you really want to get have a grip on this, I would recommend playing with this for yourself. There's a lot of resources available, but again, I just wanted to kind of introduce this and make it seem less alien than what it may sound like. And I'll do a quick recap of the different commands. So you have the git init, which means you're telling Git to start up, and you have git add. where you have files on your local repository that you made changes on, and you were ready to commit them, and then you add them, and then you commit. Commit means that you're basically saving it in the context of version control. That way, anything that you've committed, you can go back to at any point. And then finally, you push it into the repository. And then if someone made the changes in your repository while you were not working and you wanted to resume work based on the latest update, you can pull from the repository. And git clone is what you would actually do if you are taking a exact copy of what's sitting down on the repository here. And yeah, so yeah, usually we would do some sort of an exercise and kind of go back and forth in the lab. And I feel like that's the best way to learn this thing. So unfortunately, we can't do that. So just to reiterate, I would really recommend that you play around with this yourself. You can go over here. You can go to the skill session repository that I made. Where is that? And you can play around. This, no one cares what happens on this repository. So if you ever want to mess around, go for it over here. You can make your own files. You can modify these. You can push pull, commit. Yeah, this is your playground. So keep that in mind. Don't mess with other people's repositories. So that is all I have. Um, I know this is not a full-fledged kind of all-encompassing skill session. There may be a few doubts here and there, clarifications needed. If so, definitely either post on the chat or ask the question. I'm going to stop the recording now, and then if you guys want, you can ask questions right after that.